All right, welcome back to Computer Science S75. This is Lecture 5, SQL continued. So this worked out so well last time, I thought we could start with the same question. What did we do last time? Yes?
Intro to SQL.
OK, good. So an intro to SQL. So structured query language. Someone from this side now. What is SQL all about? Yeah, Jack.
It's a nice way that we can interact with the data that we can store in a MySQL database.
OK, nice way to interact with the data that you can store in a MySQL database. And in what sense, Axel, do you interact with a database?
Well, you can interact with it because it runs on a port on a server.
OK.
You can essentially just talk to it via a terminal window.
OK.
Type commands. But there is a GUI that's called PHP-MyAdmin
OK.
that we use together with the SQL.
OK, good. So we've seen at least a couple of ways to interface with a MySQL database. You can use the command line or the actual MySQL client, which is the sort of retro black and white window, which is wonderfully useful, but also limited just in terms of its screen real estate. We also looked at a tool called PHP-MyAdmin, which is popular. It's not the only tool, but it tends to be very popular. It's a coincidence for our purposes that it's actually written in PHP. We haven't looked underneath the hood, but if you did start poking around, you would see that that entire GUI is a dynamic website implemented in PHP. But there are others. If you're a Windows user, there's actually a downloadable Windows client that you can use natively on your own Windows computer and connect to, for instance, a remote MySQL database. Generally, you cannot, though, connect to far away MySQL databases, the reason being that the communication is not, by default, encrypted in any way. And indeed, MySQL itself does not really have very good built-in functionality to do the equivalent of, say, HTTPS or SSL. So it's generally best practice to keep your MySQL database on the same network as the machines that are actually talking to it. So to be more clear, you could not generally sign up for like dreamhost.com, have a MySQL database somewhere out there on the internet, and then use like this Windows client to connect to it, because everything you'd be sending, including your password, in the clear. So be mindful of that. All right, so that's how you interface with it. What kinds of queries or statements did we see last time are possible?
Insert into.
Insert into. So this is for inserting rows into a table. Recall that MySQL databases are relational databases, which means they're rows and columns. What other statements did we see?
Select, and then what you want to select, star, a wildcard star, or an actual.
Good. So we saw select queries, like select star from the table name. And that gives you everything. Or you can say select x, comma y, comma z. That will just give you those three fields. And then we introduced the notion of a predicate. And a predicate lets you filter that result set. Much like XPath lets you filter the node set that comes back. You can say where user ID equals 1, or where email address equals jharvard at something dot something, or the like. So you can filter your queries, and you can even Boolean and or them together. So you can say, give me anyone whose gender is male or gender is female. So you can get back everyone in that way, even though star would suffice in a case like that. So in short, we have this ability to filter our results. So that's select. Talked about insert. There's delete. We haven't really used this one yet, but you can use delete to delete rows, as you'll find. What's another? Yeah. Update. So update is for actually updating existing rows. This might make sense if a user updates their password, their name, their phone number, whatever the case may be. So for those unfamiliar, realize that this kind of database follows a paradigm that has kind of a silly acronym associated with it, but handy to know. This is literally the CRUD model for database queries. Anyone want to take a stab at guessing what this acronym means? It's really kind of stupid, at least the acronym. But the capabilities that it's describing is actually quite common. So C is for, yeah?
It might be create, read, and then something, and then delete.
So close, yes. What's the something? What's the U? Update. That's all it is. So create, read, update, delete. These are the incarnation of this acronym in SQL is what we've already said. Create is insert. Read is select, update is update, and delete is delete. But you'll find that in other contexts where you have this kind of expressive capabilities, that it follows this so-called CRUD model. So just FYI if you come across that. All right, so let's introduce a couple of new features now of SQL, and then we'll try to take a stab at designing something a little more complex than last week's users table. So recall that MySQL has a whole bunch of types. And here we have on the top left string-related ones, then dates and times, then numeric ones, then some floating point values and blobs. Let's see if we can't pluck off a few of the interesting characteristics of each of these. So when might you use a varchar field in a table? How about someone from this side again? Varchar. When should you go for a varchar? Yeah, Lewis.
Middle initial.
OK, so middle initial, why?
Because you'll know like the length of it and save space.
OK, good. So it's probably just one character, maybe two, or maybe 0. And so if that's the case, you might not necessarily want to waste space unnecessarily. So initial's not necessarily a very compelling case because we're really talking 1 or 2 bytes. So what's another scenario that's a little more compelling for a varchar?
Wouldn't you use it when you don't know the length of the thing that the user inputs?
Yes.
Like username or name.
Good. So for something where you really don't know the length, in an initial, I mean, most of the time it's 1 or 0, maybe 2, but I'm hard-pressed to even think of a 2-letter one. So for something that's a little more variable by nature, email address or name, then a varchar might be reasonable, because then you can say anyone's name can be up to 30 characters, but frankly, most people's names are a few characters, 10 maybe, if that. So why waste 22 or so additional characters, bytes, in your database, storing them unnecessarily if you don't need them? So there's a price we pay, though, for this. What's the downside of saying variable length chars as opposed to just a char field? Yeah? Yeah, so searching is most likely slower, even if it's imperceptible for certain cases. In large-scale scenarios where you have many, many, many rows of data in your database and you actually want to search those rows efficiently, one of the upsides of using a char, which by contrast is a fixed length field, is that you can generally search that field more efficiently because you don't have sort of this variable length to your cells in that table, so to speak. Rather, everything's fixed length. So just like an array allows you random access, similarly, might you be able to leverage the idea of random access in your column if all of the lengths are identical, 8 bytes, 6 bytes, or the like. The downside, of course, of a fixed length is that if your middle initial is just 1 letter, or if your email address is fewer than the fixed length you've come up with, well, then you're just wasting space. So it's a trade-off. We just don't get anything for free. What about text fields? Why did we introduce those? When are they useful? Yeah?
I think text was for like longer texts.
OK, so longer texts.
They were very much bigger than what you would typically say the length of the varchar. So text would be very much bigger than varchar.
Good, so much bigger than a varchar typically. So if it's like an essay field, if it's like a college application kind of thing where you want people to upload big blobs of actually, college essays are what, like 500 words, 1,000? So probably not a good scenario there. But if it's a much larger corpus of text, maybe it's the contents of a web page that you screen scraped and you want to store all of that data in just a big chunk of text, maybe you would use a text field. And one of the upsides of that, as we'll probably encounter in PHP-MyAdmin again tonight, is that you can specify that you want to have a full text index on it, which means you can use Google-like queries to search for keywords in that field, and you don't get those same capabilities in, for instance, a varchar or a char itself. So what does this mean? Well, typically, when you're using a varchar or a char, you can say something like this. Select star from users where what might be reasonable. How about, let's say, where city, state, whoops, autocomplete, where city, state, like, and now I don't necessarily know what their state is going to be, but I want to search for all states, let's say, containing the word, let's say, new. I don't know why I want to do this, but I want things like New York, New London. I want to get back all of the rows in the table where people are from towns whose names contain the word new. Completely arbitrary, this particular example. But how can I express this? Well, there's the like operator in SQL, whereby you can pattern match. And the fact that I've used these percent signs happens to be the wildcard character in the context of a predicate. So in this context, it's not the star. It's, in fact, the %, but this allows me to do pattern matching inside of a char field or a varchar field. However, if I instead make something a text field, then I can actually use a more powerful matching expression that allows me to say, give me all of the things that match this keyword and this one, and then your database engine can even rank them in terms of relevance, which might be advantageous if you're building a search engine for your site or the like. But to do that, it needs to be a text field. This is typically the more common one when you're just trying to look up queries. And you'll see this perhaps in MySQL if you actually leverage its search tab, which we didn't use last week, but you'll see it among the various options. All right, so dates and date times and years. Why use something like a date or a date time or a year field when clearly you could implement these yourself with just char fields or varchars? What's the point? Yeah.
It's probably more standardized and made more efficient.
Good. So more standardized and arguably could be made more efficient. For instance, to represent a year, we humans would typically write out 4 characters, but maybe a computer can do that a little more efficiently by storing the number of years from some offset, 1970. Now that would be dumb in this case because then you can never store other years, but it stands to reason that the computer could come up with a more efficient representation than you, plus it is indeed standardized. You also have the ability in MySQL to call functions that are built into the database engine itself, so you can manipulate things like dates and times, just like you can actually do in PHP and in other languages. But if you ask for a date, you can get it back in a date time, rather. You can get it back in your preferred format. Maybe it's 24-hour time, 12-hour time. You get that kind of flexibility. And so it's standardized, and it's better typed inside of your database. So it's not just some free-form string that you're trusting yourself and other developers to actually insert reliably. And in terms of numbers, tiny int, small int, medium int, and big int. So int is pretty common to use. Facebook, for instance, used ints early on for its IDs. But what's the downside of using an int for things like Facebook IDs? Yeah.
You eventually get a lot of them, and you might run out of what you can store in it.
Yeah, exactly. So there is a finite number of ints, which in this case are 32-bit values. And if they're unsigned, you have as many as 4 billion values, which frankly would be a good problem to have if your site has more than 4 billion users and therefore you've overflowed an int. But you got to think about it. In Facebook's case, people are signing up for fake accounts, and they already had like 800 million legitimate users. So they're getting up there anyway. And so it was definitely a scenario in which they would not have wanted to use 32-bit ints long term, just because you're fixed in the maximum number of values that you can use there. So frankly, these days, if you're doing anything where you anticipate a huge number of rows, it's not unreasonable to use a big int, which would be a 64-bit value. And what kinds of scenarios? Well, probably not users. You don't need 2 to the 64 possible users in your system, most likely. But if you're writing things out like log files, or you're recording transactions of some sort where you have no idea how many widgets you're going to sell in your e-commerce site, or you just don't want to have to bound yourself, it's probably worth spending an extra 32 bits just to ensure that you'll have a higher probability of uniqueness long term, especially when consider the auto increment feature. And this is kind of one of the little downsides of it. What was the auto increment feature of a numeric field? Yeah.
If you add auto increment, it's automatically going to add unto itself. So you're going to have, say, an automatic unique ID.
Exactly.
So you don't have to query the database for the largest number, take it back to the server, +1, and then insert.
Exactly. So with auto increment, by contrast, you can tell the database this field here, let's call it ID, as we did with the users table last week. You can just say this should be a number, and it should start at 1, and it should forever auto increment for each additional insertion that I do. And that's fine, and you can get up to 2 billion with signed numbers, 4 billion with unsigned, or 2 to the 64 with unsigned 64-bit numbers. But what you don't get is the ability to reuse numbers. So if you delete, for instance, a user from that table, their number is not going to get reused. So you could end up getting sparsely populated data, which isn't necessarily a bad thing. But that just means that even though you might not have 4 billion users, you might have used 4 billion IDs. It just so happens that a bunch of those people deleted their accounts. Now, you could go through and change around people's IDs. But if you do use Facebook, just imagine how many things would break if you started changing people's IDs. Any URLs people had copied and pasted around the world containing a user ID would now be invalid if you're changing people's IDs around. So that's probably a bad idea. And frankly, it's just expensive to go back and figure out where are the holes in your data. So most databases just kind of forge ahead blindly to higher and higher numbers. So at least you have more wiggle room with something like a 64-bit value. But so those are some of the gotchas. All right, so floating point numbers, doubles, are what you would expect in most languages. Decimal's an interesting one, and it'll come up probably in the context for you of Project 1, which we'll talk about tonight, where you want to represent money somehow, dollars and cents for at least US currency. What's the problem with representing money in general with a floating point value in any language, really? Yeah.
If you ever want to display it and it has a cent value that rounds like 90 cents or 80 cents, it cuts off the last zero and it just looks like $12.9 or something like that.
OK, so sure. So there is this aesthetic issue involved in floating point numbers where if the amount is $1.90, as we would see it on a store, well, the zero is not strictly necessary for that number's representation. So a computer might, by default, might just do $1.9, and that's it. So that problem we can fix pretty easily by just formatting it as a correct string with 2 digits. But there's an underlying problem whenever you use floating point values, whether it's a float or a double, 32-bit or a 64-bit real number. What's the problem? Why should you not store money as floats or doubles? Yeah, Jack.
Rounding issues?
Rounding issues. What do you mean?
Like, from my experience with floats and doubles, occasionally if you try to store money in them or any value in them, and you want to get down to the exact value back in the end, you're going to end up with like .999 something going
Good.
off.
Exactly. In fact, there's an infinite number of numbers that you cannot represent precisely using a floating point value, whether it's a 32-bit float or a 64-bit double. And you can think of it as follows. If you have a 32-bit value, or even a bigger one, a 64-bit value, there's still a finite number of numbers that you can represent with those bits. However, how many real numbers are there in the world, where a real number in this case is something with a decimal point and a number before and after it? How many of those are there? So there's an infinite, right? But if you only have a finite number of ways of representing real numbers in a computer, as you do with a float or double, but there's an infinite number of them, you're going to have to round or cut corners somewhere. So the problem of representing something important like money using floating point values is that you might be trying to represent $1.90. But you know what? The closest the computer can actually get using its bits is $1.89 or $1.89.9999, which is not exactly right. So how many of you have ever seen Office Space, the movie? Just you and me? Just Lewis and me? Or Superman 3? Even less likely. Chris saw that one as well. OK, so if you haven't, this is a good excuse to watch a movie. You can say it's for class. Watch the movie Office Space, which is the funnier of the two. And there's a scene in this movie. This is not a spoiler at all. But there's a scene in this. It's kind of a spoiler. But by now you should have seen this. The movie came out like 10 years ago. So there's a scene in the movie where these guys are trying to steal money from their company because the company's computers are not taking into account this kind of imprecision of value. So essentially, they write a program that says anytime there's an amount like $1.89, or rather, let's say $1.90.000001, which would normally be shown as just $1.90. There's still some fractions of cents there, right? There's an opportunity to steal those fractions of cents, but the company would never know because all they see on their paperwork is 1.90. So they write a program to steal all of those fractions of pennies, and hilarity ensues as a result. So real-world example of floating point imprecision. Excellent movie called Office Space. All right, so blobs. We haven't used them, not really going to use them, but what could they be used for? Yeah?
Images?
Images, yeah, so binary objects of some sort. Binary large objects, but again, I would generally recommend that if you need to store binary data, you store in a folder on the file system and store in your database instead what? Yeah, just the path, the file name or the path to it, whatever directory it happens to be stored in plus its file name, something like that. All right, so here are just a couple of functions that are germane to the data types built into MySQL. If you go to that URL there, you'll see a whole bunch of others that are built in, things like averaging and summation and the like. But here's just two very common ones, date formatting and time formatting. So long as you have stored a date or a time in one of those date-time related fields we looked at, literally date, time, year, and so forth, you can call this function in your SQL query to get back a different representation of that. So how does this work in practice? Well, instead of doing something like select sales date from, okay, autocomplete is going to keep doing this to us. Select sales date from my table. If instead you want to not get back something like, and actually let me change it to this. If you don't want to get something back that's not very user-friendly, like 2012, 07, 01 at 2300 hours, 1 minute, and 23 seconds, like this is what will come back by default. That's not very user-friendly. You could get that back and then use something like PHP to massage it into something a little more user-friendly. Or you can actually say date format, passing this in, and then passing in something like YMD to just get back the month. Or you could do something like M/D to just get back month/day, and so forth. And you can do something similar with times as well. All right. So just a couple of functions, but realize that functionality exists. But now let's take a look at one other fundamentally different approach from last time. So here's a snippet of representative code that actually doesn't do all that much besides connecting to a database. But it uses different functions than we used last time. What were the functions we used last week to implement our various login examples, to connect to a database and select the database and so forth? Yeah? Good. So MySQL_connect. Then there was MySQL_select_DB for selecting a database. Then there was MySQL query for querying the database. And there's a whole bunch of others. In fact, if we look these up in the documentation, let me go ahead and pull up a browser. Let me go ahead and search for MySQL PHP. That'll pull up the manual page on php.net that has a listing of all of the various functions here. And the ones we're about to get back here, albeit a little slowly every time we try to do this. There we go. All right, so you can see here a list of most of the MySQL functions. The rest are cut off. And there's more here than we probably are going to care to ever use. But MySQL Connect is up there at top. MySQL Fetch Assoc is there. There's another one, MySQL Fetch Array, which allows you to get back a numeric array if you would prefer. There's MySQL Fetch Object. If familiar with object-oriented programming, you can actually have the database, or rather the library, return to you a PHP object inside of which are properties that represent the various cells from a row, and a whole bunch of other ones here. There's MySQL numRows. We use that to figure out how many rows had come back in our result set, and so forth. But there's a downside of using this built-in library in PHP. One is the function names are atrocious. The worst of them is, recall, MySQL real_escape_string. Now, just because it's god-awfully named doesn't mean it's a bad thing to use. In fact, not using it is a far worse sin than having used that particular name, since you'll be vulnerable to SQL injection attacks, which we talked briefly about last time, but we'll look again more closely at the end of the semester when we focus on security. But also, you're doing a couple of things that are a little short-sighted. One, you have to you're tied now to MySQL. If you ever decide, or your new boss ever decides, or whatever, someone decides to change the database from MySQL to something called PostgreSQL or Oracle or the like, you literally have to go through and rewrite all of your code, or at least do a massive find and replace, and even then some things are likely to break. So you've just committed yourself from day one to using MySQL. And maybe that's fine, and maybe 9 times out of 10 that's fine, but for the other scenario, is it really worth the aggravation down the line? But more compellingly, too, it's so much easier to make mistakes, right? As soon as you start writing code for Project 1, which involves using a database, the very first time you forget to call MySQL real escape string, that's all it takes for your site to get compromised. And at that point, it would be so nice if instead someone else could do the scrubbing of data for you, so that the burden is not on every one of us in this room to have to call this particular function every time we want to protect ourselves against these kinds of attacks. Better would be to use a library that does that kind of escaping for us. So enter into the picture something called PDO, Portable Data Objects, which refers to code like this that abstracts away the detail of what kind of database you're using. And by that I mean you can use the exact same code to talk to MySQL, to talk to Oracle, Microsoft Access, even SQLite, which recall is just a little binary file that you store locally on disk. So you have this layer of abstraction now so that the code you write doesn't have to change at all if you do change your database. The only thing you have to change is a variable or an argument that you pass in. Up here at the top, for instance, notice that I've said a variable called DSN by convention, MySQL :dbname equals lecture. So that's really no different from last time. Host equals 127.0.0.1. And the only part of that line that I would have to change if I move to something like Oracle is the one mention of MySQL. So essentially, that's a unique string that identifies for this library what type of driver to use, MySQL, Oracle, or the like, and then what the database name is and what the host actually is. And then the user and password have nothing to do really with the type of database you're using. So what do I have now? So for those unfamiliar with tries and catches, this simply has to do with exception handling. So this doesn't have anything fundamentally to do to this, with this idea of using this library. But the way it works is that when you call new PDO, and the jargon here is instantiating a new object of type PDO, you pass in a couple of 3 arguments, the connection string, user, and password. And then if something goes wrong, rather than returning false, as is the case with a lot of PHP functions, rather than triggering an error, which generally forces your program to die, it instead does what's called throws an exception. And if your code has not been designed to catch any such exceptions, your program will quit right then and there, crashing on the user effectively. So instead, if we say prepare to catch a PDO exception, and if one happens, let's call it $E, at least you can, in a slightly more user-friendly way, handle that kind of error. Now, what might the error be? Username or password is wrong, MySQL is down, something like that. But this line of code essentially becomes our equivalent now of MySQL_connect. Now, beyond this, and you'll see in section tonight, as well as with this tutorial, which we refer to in Project 1, pretty much all of the lessons from last time and all of the lessons from tonight about SQL itself still apply. This doesn't change SQL. This doesn't change your selects or your updates or your inserts or deletes. All it changes really is how you initially connect to the database, and it also just changes what functions you call. Instead of MySQL query, you're instead going to execute a function called execute, or another one called prepare. And the nice thing about prepare is that it creates, in database terminology, what's called a prepared statement. This is sort of like a compiled SQL string. So if you have a query, you execute a whole lot. Select star from table where foo equals bar. If you're constantly executing that string, that query, but maybe only one part of it is changing. Maybe the value you're searching for is what's changing. So select star from users where ID equals something. If you want to prepare that query, but call it again and again and again, and every time you call it, you just want to change what? The ID that you're searching for, you can call PDO's prepare function, and this will essentially optimize that query to just have one part of it changed on each iteration. And the other upside is when you plug in an ID to a prepared statement, or really plug in any value to a prepared statement, guess what the library does for you for free? Yeah. It escapes it. So you no longer have to think about any of that. So understanding it's still good, certainly, but you no longer have to worry about trusting yourself to write code that's 100% correct when it comes to security. So again, we'll see some examples tonight in section. This is what we'll have you use in Project 1, but realize this is just a layer on top of those MySQL functions that come built into PHP. Now there's the PDO library, which just solves a couple of problems that you might otherwise run into. All right, so last time we had life pretty simple. We only had one table called users, and what kinds of fields did we have in our users table? Yeah. Username, password, and what else? We eventually added a user ID. Why did we introduce a user ID? Yeah. Yeah, we wanted a primary key which uniquely identifies every row in the table. But why not just use username?
Because username may be duplicated and maybe the unique one.
OK, well, let's assume that usernames by design will be unique, just like the numeric IDs will be unique. But what was better about using an integer for the ID, the unique identifier, as opposed to just trusting that usernames are unique? Yeah. Yeah, exactly. It's really a performance thing. If users can have variable length usernames, 3 characters, 4, maybe even 12 characters long, if you want to look up a user, that means you have to search for 3 or 4 or 12 characters. By contrast, if you also assign users a unique numeric identifier like an int or a big int, then you're spending exactly 4 bytes or maybe 8 bytes on every user. So you again have a fixed width table effectively, and it's just much more efficient in general to search for integers, whether they're 32 or 64 bits, than for arbitrary length strings. So that's the reason we ultimately introduced the ID field. But the problem, too, is that we started telling the story about normalization. And we started talking about, well, what if users have cities and states and zip codes? There was obviously going to be some redundancy. And so we proposed factoring out what from a users table if we also want to store their addresses, cities and states and zips and so forth. Well, how did we solve that inefficiency? Yeah.
We store the zip code instead of the actual address.
Yeah.
City and,
Good. So rather than store Cambridge, Mass, 02138, Cambridge, Mass, 02138, Cambridge, Mass, it's already getting boring to say. And imagine just storing that again and again and again and again for every user. We can do better than this. Well, what do we minimally need to identify users' locales? Probably just the zip code. So now we could have a zips table that has city, state, and zip as its columns. But the only thing we put in the users table is which of those 3 fields? The zip code, exactly. So that's nice, but it feels like the price I'm now paying is every time I want to look up a user and figure out their address, now I have to do a select on the users table and also another on the zips table. And my God, imagine if we did this with other pieces of data as well. All right, if we had other common pieces of data, do we have to now select from a 3rd table, a 4th table? It feels like we're solving one problem, but introducing others, namely ones related to performance. But thankfully, relational databases allow you to join tables together. So let's take a look at this as an example. So at top right here, there's a couple tables. This is taken from a site called w3schools.com, which has varying degrees of accuracy, but this particular example is decent to work with. We have 2 tables, employees and orders. And in the employees table, we have a field called employee_ID, and then another field called name. So it looks like Ola has an employee ID of 01, Tova has one of 02, Stephen of 03, and so forth. So nothing too unreasonable there. And now under orders, we have a product ID, a product, and an employee ID table that apparently is specifying who sold these products. So it's just some kind of log. Maybe it's for commissions, so you know who to pay and how much to pay of who sold what. Let's start finding some faults with this design and see if we can't fix, but let's also consider what they did that wasn't bad. So at the top, the employees table, if you were doing this table, what would you have done differently? Isaac, that counts as a hand up. Find fault with the employees table at the moment. Not sure? Oh. Sure. Oh, that's actually, I forget your name. Yeah. Scott, yes. Find fault with the employees table.
I mean, maybe you need to separate the name as the first name and second.
OK, good. So we have a database, right? We might as well tease apart first name and last name, because storing it with just the commas is just completely unnecessary. It's as though we've created a fake column by sort of merging together the idea of a CSV with a database table. Why not just put last name field and first name field? So we could do that. So that's pretty good. All right, and what else? Well, for some reason, these employee IDs are written as 01, 02, which suggests that they're using like a char or varchar, and that's just dumb at this point, right? It should just be a number, and if it's an actual number, it would suggest that there's not a prefix of 0, but now we're just kind of inferring from the example. But that could be a potential fault. So now what about orders? Well, it looks like here that what they have done, which is good, is they have not put the employees' names in the orders table. They've just put the employee IDs. So this is similar conceptually then to not putting city, state, zip in a users table, just putting the zip. So that seems like they made a smart decision. What was kind of stupid, though, nonetheless? Find fault with the orders table now. Jack, that counts as a hand up. Everyone has to stop scratching their head. Find fault with the orders table.
I don't really see much fault in the orders table, to be honest, except for
I'm gonna decline that one. So no, can't reuse that idea. There's still a fault here, though. Yeah. You could have an order ID. Yeah, so we have no way of uniquely identifying these orders, and maybe there's no use case for it, but that does seem inconsistent with the idea of having employee IDs and product IDs. And even beyond that, there's pretty bad fault in the orders table. Axel?
I don't know if this counts as a fault, but I really wouldn't order the table from employee ID. I would order it from the product ID, so it's easier to see.
OK, order the table from product ID. But isn't that what they've done? It's on the left?
Oh, yes, but what about 235 and 236 and all of those?
Oh, 230.
Is that just arbitrary?
Oh, I see. So it is an arbitrary example. Maybe those rows got deleted because they were canceled, even though that's kind of a lot of cancellations. Jack?
I figured it. They have the product ID and the product both stored in the table, while I guess if they have a product ID, they can store that somewhere else.
Exactly.
And end up with printer for every product ID 234.
Exactly. So whoever made this table kind of got it half right, and they did factor out the employee ID and put only the employee ID here, but then they sort of forgot that lesson learned and seemed to be duplicating product name, product name, product name, product name, and you can't see it here, but suppose another person orders another printer. Well, what's going to end up in the next row? Well, it's going to be a product ID of 234, but then the word printer in the second column, and then whoever the employee ID is that sold them that printer. So we probably should introduce another table. What should that table be called reasonably? Products, right? So like a product table, inside of which is a product ID field and a name field, which then suggests that how should we fix the orders table? What should go? Yeah, Isaac.
Product ID.
So just keep the product IDs and ditch what?
And take out the product.
Exactly, to ditch the product. Now, if you continue this kind of normalization, as it's called, your database starts to get very cleanly designed. And by clean, I mean there is only one authoritative place to find out what the name is of a product. You check the products table, and there's only one mention of printer or table or chair. It's not duplicated all over the place. And this is good, obviously, if you just change the name of something. You wouldn't want to have to go through all of your various tables looking for all of the redundantly named things just so you can update them. So that's good. But again, it feels like I'm creating a huge amount of work for myself now, because whereas in a simple world, I just select star from one table, now I have like 3 different tables. And how do I select data simultaneously so that the data I get back is representative of a given moment of time and not from this second followed by another second followed by another second, whereby your queries themselves might be some number of seconds or milliseconds apart? How do I get a snapshot in time? Well, we can actually do this all at once. And we can do this with a couple of different syntaxes. But so let's try this. Let's assume for the moment that this is good enough, even though they're the faults we already found. If we assume these table structures, though, how can we go about querying data and getting it back all at once? Well, here's some slightly new syntax, and I've written on 3 lines, really just for readability. SQL doesn't care. It only matters when that the whole expression is syntactically valid. So select employees.name, comma, orders.product. Now, what does this mean? Well, employees.name, as you can probably infer, is referring to the name field of what table? Employees. So that's all. The dot notation does exactly that. And we saw the dot notation actually in phpMyAdmin last week. Orders.product, same idea. Select the product name from the orders table. Where do you want to select those fields from? It feels a little redundant, but this is just the way it is. You then specify what tables this query is selecting data from. So you have to say from employees, comma, orders. And it doesn't matter the order in which you say them, but you have to say the table names that you want to involve in this query. But now I'm doing this last predicate, and this is definitely more involved than the ones we've looked at briefly thus far, where employees.employeeID equals orders.employeeID. In English, what is that predicate doing for us? Yeah.
It's like set out a cross-reference between the 2 tables. Connect the table. Tables together.
Exactly. It's creating a cross-reference of sort between the 2 tables, namely employees and orders, and it's explaining to the database how to join those 2 tables together. Now, I can sort of simulate this with my fingers. Let me pull up the data over here. What is obviously the one common field between the employees table and the orders table? So it's the employee ID, right? That's the only one that's in both. So if we again kind of do the little physical depiction I did of this with my fingers last week. Suppose that here's employees, and suppose that these are the employee IDs, the tips of my fingers here. And now the orders table also has employee ID, and it's the tips of my fingers here. Effectively, what that query is doing by saying match employees.employee ID equals orders.employee ID, it's saying to line up the employee's ID. So if this is 001 on the left, it's 01 on the right. If it's 03 on the left, it's 03 on the right. So you kind of join these things together using identical employee IDs. And what does this whole query return? Well, it returns a result set, which recalls a fancy way of saying a temporary table. That table looks like this, where these fields have been conjoined somehow. And each row represents the combination of some data from one table with the other table. So let's actually try to see this in practice. Let's go and recreate this, then we'll improve upon it. So let me go over to phpMyAdmin in the appliance, and I'm going to go ahead and create a new database. I'm going to go ahead and call this jharvard Monday, just for kicks today. So now we have a clean database. We won't commingle it with last time's. Let me choose the Monday database. And now let's create a table. Now, in general, I would not do what W3 Schools did here with capitalization, but let's just keep it identical. So we'll create an employees table. And how many columns did it have? 2. So let's do that. And then the first one was called employee underscore ID. It could be an int, but let's just do big int just to be different this time. And then it had a name field, which should be of what type, probably? Yeah, so let's go with varchar. Now we have to make a design decision. How many characters should a name be? 50? OK, so let's 50. Something reasonable, but be consistent in general, probably. And now what else do we want to choose here? Should either ID or employee name be null? Probably not. I want both, really, in my database. Index. Should employee ID be a primary, unique index, or full text? Primary. Why? Because it hopefully uniquely identifies the user. And we're going to kind of clean up one detail. We're not going to have prefixed leading zeros in our employee IDs. Let's actually use a number, like a big int. How about the name? Should we make the names unique? Right? There's lots of like Mike Smiths in the world. It would kind of be unfortunate if we could only hire one at our company. So we probably should not impose that. When might I want to define an index on a field? So it's not unique index. It's just an index. What was the advantage of defining an index? We didn't really talk about this, but just think instinctively. Why would you want to index, so to speak, a database field? For searchability, for performance, right? If a field is not indexed and you want to search on it, you essentially have to do linear search. You have to search the whole column to find the values you're looking for. But if instead you as the database designer say, index this field, you're essentially providing a hint to MySQL that you or someone will maybe want to search on this field. So please do some effort up front to optimize those future searches. And it will create some kind of tree structure. It's generally called the B tree structure that gives us more like logarithmic search time instead of linear search time, which for those unfamiliar just means it will be faster. How about AI, which is just a shorthand way of saying auto increment? Should name or ID be auto increment? Probably ID if we don't want to have to deal with managing those ourselves. In terms of defaults, we probably don't want to give people default names or anything like that, so let's leave everything else alone. Lastly, let me mention this. We'll come back to this. We didn't choose this last time, but notice under Database Engine, there are different engines you can use. And I made the comparison with like NTFS and HFS Plus for file systems, if you're familiar with those worlds. But for now, we're going to leave it on the default, InnoDB. But later, we'll see what the actual implications are of not giving that choice much thought. There will be some trade-offs. So let's save. All right, so what query was just executed? Again, here's one of the upsides of phpMyAdmin. It kind of teaches you as you go by telling you what query it actually executed to do your bidding just a moment ago. So we executed a create table statement. So now let's go ahead and create a table. And let's go ahead and choose create table. Orders, how many columns does this thing have? It has 3 at the moment, and we'll just deal with the imperfections of it now. And those 3 columns were what? Product ID, so prod ID, and then we had product, and then we had what as the last field? Good, employee ID. All right, so for product ID, What should this guy be? Let's go with big int. If we're going to use big ints everywhere, let's just use them for this guy too. Product should be what? Varchar. How long should a product's name be? Depends on what you're selling. We are selling printers, tables, and chairs. 20. All right. The marketing people will be upset with you when they come up with a longer word, but that's okay. Employee ID should be what? Big int for consistency now, right? Because this is, as we'll call it, a foreign key, whereas in the other table, it was a primary key. All right, we'll leave the length blank there. Let's see. Null, should any of these fields be null? Probably not, unless you want no one to be able to sell these things. Index, which should product ID be? Sorry? Primary key. So this one's kind of a trick question. So I would argue that primary key is not appropriate here. But why? Here are the tables again. Yeah.
It's not really that you want to search for it. You want to link the product to the employee.
True, but I would argue I would want to search on product ID. Suppose I want to know how many chairs have we sold. I could do a select star from orders where product ID equals 865. So searching on it's compelling. But primary key means it uniquely identifies the row. So what would the implication be of making product ID unique and a primary key at that in this particular table? Yeah.
If you have more than one chair in your table, which you're probably going to have, you have a problem.
Exactly. We could only ever sell one printer or one table or one chair, or rather, an individual employee could only sell one printer or one table or one chair because, again, of the definition, a primary key must uniquely identify a row. So if you have employee number 1, if Ola sells a second printer, what should the row be? It should be 234 printer 01. But that would violate the primary key constraint. So really, someone else offered up the solution earlier. What field is really missing from the orders table that should be there? Or maybe not item ID, but let's call it order ID. So something that uniquely identifies the order. And if we did introduce that, I would propose making order ID the primary key. Because then you can start at 1 and 2 and 3. And for everything you sell, you can increment the order ID. So what might we want to do then with the poorly designed table that we have here? Well, let's go ahead and I'm going to propose indexing it. It's not unique, but this way I can search on it, which is reasonable to want to search on an ID field. Now, the next field was name. Should we have any keys on the product name?
No.
OK, I heard a no. Anyone want to argue the opposite? And then we'll flesh out which is best. So I'll play the contrarian. So I'm going to propose yes, I do want an index on here. Why might I be taking that position, though? And again, the field in question is the name of the product. Yeah? Yeah, what if I want to search for all tables that were sold? So I'm, the salesperson. I don't really remember what the number is for that product, but I want to check how many chairs have I sold. Or my boss wants to check how many chairs have I sold. And maybe we have different types of chairs. Maybe we have products called big chair, small chair, white chair, black chair, any kind of longer product name that has the keyword chair. But I, like a person just using a computer, I just want to do the equivalent of like a Google search. I want to search for chair. Now, what's the SQL keyword that we can use to do those kinds of keyword searches? Like. So we saw like earlier. So actually, the like expression here would probably be quote unquote percent chair percent, because that would find me any products that have the word chair in them. Now, that could fail if there's some weird word out there that has chair as a prefix or a suffix or as a substring, but it's probably good enough for our purposes here. So why might I want to index then the name if I want to search on it? Now, maybe I do, maybe I don't, but if I do, I should have that as an index, but not unique, because then I could only sell one chair, for instance. Now, lastly, employee ID. Should employee ID be a primary key, unique, or index? Full text isn't relevant because it's not a text field. Yeah. Exactly. We probably do want to index it because it is an ID, and we want to not only search on it here, we also want to do that join thing. And in fact, anytime you're joining one table with another, the field or fields that you want to join on should be defined as having indexes for performance. Otherwise, again, it's a very expensive operation. Can you remind me, what's your name again? Ben. Okay. Trying to get them all down. All right. So let's finish this up. Let's make this an index. And should any of these be auto increment? Good. If we had, let's keep calling it an order ID, then yes, that would be reasonable if order ID uniquely identifies that order. But as it stands now, no, I don't want these auto-incrementing because I'm going to deliberately specify who sold what and what that ID actually is. So let me go ahead and click Save. And now let's go ahead and look back at this query. So when I select employees.name, orders.product from employees, orders, where employee ID in one table equals employee ID in the other, I get back this sort of visual effect. And what does the temporary table look like? Well, if we kind of do that query, we get back this table. So it's a temporary table. It's my result set. It has some number of rows, in this case 3. And I have Ola and Stephen and all of the items that they sold. But this is a little confusing to me. I thought I have colleagues named Tova and Carrie also. Why are they not in my table? What's the mistake or problem here, Isaac?
Well, they didn't order anything.
Yeah. This isn't a bug, right? It's just that neither of them is selling very much right now. Because look at the orders table. Who sold things? Employee ID 1 and then 3. And 3 sold 2 things. So Tova and Carrie haven't sold anything. So this is indeed correct. It just so happens that only Stephen and Ola have sold something from among the products. So there's another syntax now we can use to do this join. This is what's generally called an implicit join. Why is it implicit? Well, I have nowhere used literally the word join. And you're just kind of implicitly saying, create a new table that's the result of joining these two tables by way of the where clause that I had there. But we can be more explicit here, and we can do something like this. Notice this is after, before. After, before. So here's the after version. What's different? I still say select employees.name, orders.product, but this time I say from employees join orders. So I explicitly say I want to join employees and orders, but how do I want to join them? I have to specify on employee ID equals employee ID from each of the respective tables. So the end result is identical. And it's really up to you as to which one is more clear. Frankly, I almost always go with the join syntax like this, just because it's super explicit as to what I'm joining on what, and it's a little more clear to me what's going on. And again, the white space where I've hit enter is meaningless. I just did this for formatting reasons on the screen. So that you've heard it now, there's other types of joins. There are left joins, there are right joins, and outer and inner. And now what the relevance is for us is it won't really affect you with project 1, but sometimes there are corner cases. Like what if you don't have, suppose that you, let's see, who's number 3? Suppose that Stephen was fired. He no longer works at the company, so you go ahead and delete him from the employees table. You probably don't want to lose his entire sales history, because if you're trying to balance the books, you want to know what you sold and who sold it, even if that person's not there. But the problem, though, is that if Stephen is not in the employees table anymore, and you do a join on employee ID, those rows are going to disappear. They will not appear in the output, and we won't know that Stephen sold both a table and a chair. So by using left join or right join, you can essentially say which of your two tables that you're joining should carry a little more weight. So in other words, if in this case I did a right join, now which is the table on the left and which is the right? It's not quite obvious from the way I've formatted the text here, but notice I said from employees join orders. If you write that out in a sentence, which one's on the left? Employees, and then orders. So employees join orders. If you write it out, you have a left table and a right table, even though mine happen to be on separate lines. So what's the implication then? If I actually said from employees right join orders, that means that every relevant row in the orders table should be included in the results set. And if it just so happens that there is no corresponding employee ID in the employees table, because Stephen was let go. That's okay. Still give me a row for all of the stuff he sold, but put null there and null there. You don't know who sold it, but you don't want to lose track of the fact that it was sold. Now, by contrast, a left join would not solve this problem. But if something were missing from the orders table, then maybe you do a left join. But the idea here is that you bias it toward one table or the other just so that you don't accidentally drop some rows. All right. Any questions on joins? And we'll try to make this more near-term relevant when we discuss later today project 1. All right, so let's go ahead and take a 5-minute break, but the teaser for now is we're going to come back and talk about milk and going to the store and putting in a refrigerator. So hopefully that will get you to come back all excited. Let's take a 5-minute break. All right, so consider the following scenario. You have a roommate, and you have a refrigerator, and you both like milk. And you open one of you gets home one day, and you open the fridge, and you're out of milk. And so you close the fridge, you head outside, you walk across the street to CVS, and you get in line to buy some milk. And the lines at CVS these days are always ridiculously long because they have those self-checkout machines. So it's perfect because now your roommate comes home while you're still waiting in line at the self-checkout machine at CVS. He or she discovers, oh, you're out of milk. He or she closes the refrigerator, walks outside, goes to the supermarket instead of CVS, so you don't actually cross paths. Then some number of minutes later, you both get home, and voila, you now have twice as much milk. And milk spoils, so this was not a very good plan because you like milk, but you don't really like milk, so it's not like you're going to drink 2 gallons of milk. So now you've wasted some money and some milk. All right, so horrible problem, right? So how do you solve this in the real world? How do you avoid getting twice as much milk? Yes?
I mean, you could just write a note on the fridge that you might have gone out and bought
Okay, good. Right, so a totally reasonable solution. If you are the first one to come home and you realize there's no milk, just leave your roommate a note, right? It's the courteous thing to do. You'll go get the milk. He or she will appreciate it. And so when he or she then comes home, opens the fridge door and realizes, oh, there's no milk, he or she does not take it upon themselves to go to the store as well. So this is good. A note is a very reasonable thing, and we can actually kind of ramp up the metaphor a bit. And instead of saying like leaving a note on the fridge, you could be really kind of crazy and just lock the fridge altogether if you're the first person, right? Because the problem here fundamentally is that both of you are independently checking the state of the refrigerator. Now start thinking of the refrigerator as a variable that has some value. And that value is either 0 or 1, there's milk. Or maybe it's a number that indicates how many ounces of milk you have. But either way, it's a variable. Both of you at the moment in the first version of this story are independently checking its state. But the problem is that your operations of checking the variable state and updating the variable state, in other words, opening the fridge and looking, and then buying more milk, those operations are not atomic. They can happen, but there can be interruptions in between those two operations. What's the interruption here? You check the variable state. You then start to go for milk. Your roommate then checks the variable state. And you both have correct views of the world, but you, the first person, have made a decision based on that variable's initial state by walking across the street to CVS. So when you come back is when the problem ensues. So again, a note would solve this problem, assuming your roommate reads it. And if he or she is not really paying attention to Post-it notes, you could literally put a lock on the refrigerator. What would that prevent? Well, that would physically prevent your roommate from checking the value of that variable. Now, it could be a little awkward because if they're really determined to have milk, you're going to come home and they're still going to be holding onto the door because you've blocked them, so to speak. They are in what's called deadlock mode, if we really abuse this analogy to computer stuff. So they're in deadlock because nothing can actually happen there. Or they're spinning and waiting for the lock. Deadlock usually involves 2 people. So we can solve that problem in the real world. But now let's consider a related problem in the world of databases. So the same scenario arose in conversation last week when we were talking about registering for a website or buying something from a website. For instance, in a simple scenario of registration, suppose that your name is Mike Smith and someone else's name is Mike Smith. And just by bad luck, both of you hop on the internet one day and try to register for the very new Facebook.com, the next big thing. Right? And you really want Smith as your username, or Mike, or M. Smith, whatever the case may be. You both want the same username. And suppose that by bad luck, you're both sitting at your laptops and you both hit enter at the same time. Well, what happens? Well, those HTTP requests go to the server. The server has a database now, so there's some code that passes those username requests off to the database. And what's going to happen? Well, even though we like to think of computers as doing dozens of things at once, because they seem to be, really they're typically doing one thing, or maybe a finite number of things simultaneously. And in this case, let's consider a simple story whereby your two requests might have arrived at the same time at the server for the username Smith, but one of you has got to win, right? One of them will be serviced ever so quickly before the other one. So what's the problem? What if that first request is Smith available? This guy checks. But then the computer, again, needs to maintain this illusion of parallelism. So as we said last week, this thread, your request, is going to be put to sleep. Maybe for a second, probably just for a split second, at which point the other person's thread is going to be awoken, and it's going to check, is Smith available? The answer to that query is also going to be yes, if you just use a simple MySQL select statement. Right? You might select star from users where username equals Smith. If that returns 0 rows, this guy knows it's available. If that query returns 0 rows, that means this guy can have that username as well. So suppose you issue your select statement first. But then, in your next line of code, is when you actually do your insert. How do you create a new user? You insert into that table. But what's going to happen? So the first user has his choice of username, Smith, inserted. The second one, what happens? Now there's a collision, right? And so the MySQL query function or the corresponding PDO function is going to return some kind of error. And yet, why should it be an error? You told both of these Michaels that Smith is available, so this is an incorrect result. Quite bad. Now, instead, let's assume a more compelling scenario, right? OK, so what? Second Mike Smith didn't get his favorite username, so not a huge deal. But now consider the case of money or ATMs. So if you want to go to a cash machine, and suppose that you're being really crafty, you're a bad guy, and you've somehow figured out how to duplicate your plastic ATM card. That's not hard. It's just a magnetic strip. And suppose you go up to an ATM, and you cover up the cameras so there's no corner cases, and you put in the two ATM cards simultaneously, and you log in. And then you do something like, I want to do a withdrawal of $100, enter, simultaneously on these two machines. How is this story similar? Wherein lies the same problem? Axel?
When the ADM checks the account for balance or whatever, it's going to return the same value to both ADMs. So
Good.
It's essentially going to withdraw the same amount from the same balance, and the end result is going to be the same.
OK, exactly. So if it's really the same kind of story, it's just the variable you're checking now is your account balance. And suppose that you only have $100 in your account, you being the bad guy, but you've executed these queries simultaneously. So just as in the case of milk, just as in the case of the username checking, both ATMs say select star from, let's say, accounts where user ID equals 12345, where that is the unique identifier on my ATM card. And what I'm selecting this time is balance. And the balance comes back, and I say, oh, this user has $100. But both ATMs get that same answer. So what does an ATM do then next? Well, if there is $100 in the account, what should it do? It should dispense $100 from both machines. So now you've withdrawn $200, even though you only had $100, and somehow your account now is at negative 100, or worse, 0. Right? If the math just kind of works out that way and they're using an unsigned integer, because it doesn't really make sense for a bank to just give you more money than you actually have, unless you actually sign paperwork for a loan. So in the worst case, from the bank's perspective, they have just given a guy who owns $100 $200, and they don't even know it, because the account balance is now 0. So how could we have solved this problem? How could we have solved the username problem so that the expected outcome is indeed correct? Yeah?
Lock the fridge.
OK, so lock the fridge. So what does that mean in the case of the ATM? Well, you just have to ensure that after you ask a question like, how much money does this guy have, you then perform the deduction before answering any similar queries for other ATMs for that particular guy. You somehow need to make your two operations of checking balance and withdrawing money atomic, so to speak. Atomic in the sense that it's like a very small particle. It all happens at once together. So how do we do this? We don't really have a way of doing this in code just yet, because in PHP, recall, when we were doing all of those login examples last week, we called MySQL query and then MySQL query in different places of code. You want to somehow be able to execute 2 queries simultaneously. Now, you saw semicolons in use for the MySQL command line client, the black and white interface, but it's not enough to just separate your queries by semicolons and send them both to the database at once, because they can still get interrupted. You have to be more explicit when you want your database operations to be atomic, and there's a couple of ways to do that. There's this handy syntax in MySQL where you can do the following. And this doesn't quite solve the ATM example, but it does solve similar problems in that you can express yourself as follows. Insert into table, whatever it's called, columns A, B, C. What values do you want to insert for A, B, and C? Let's arbitrarily say the values 1, 2, 3. However, if one of those fields, say A, is defined as a primary key, a unique key, and if you are trying to insert a duplicate key, this syntax lets you say, don't do that. Instead, just update one of those fields' values. So what's the implication here? Let's actually take an example like, let's say, ordering something. Let's come up with a good one here. Let's actually use stock symbols. So suppose you're implementing a website for keeping track of what shares of stock someone owns. And you just want a total count. How many shares of Google do I own? How many shares of Microsoft do I own? And so forth. So in whatever table you're using to store a user's portfolio, you simply want to have one row for Google maximally, and in another column next to Google, you want the total number of shares. And if it's 1, that's fine. But if the user buys some Google shares today and then buys some more tomorrow, you want to update that same row. You do not want duplicate Google rows just because there's no need. It's inefficient. You can just update that particular value in this version of the story. So with this kind of query, you could say exactly that. Insert into table, and then in parentheses, quote unquote Google, or whatever its stock symbol is, comma something, comma 1, where the 1 is the number of shares that you're trying to buy. If, though, there is a duplicate key, well, what's likely to be the unique key here? Goog. G-O-O-G happens to be the symbol for Google. So if you already have a row in this table with a key of Goog, what is this code telling it to do? It's instead saying don't insert a new row with the values A, B, C. Instead, just update the existing row's C value by incrementing it by 1. So in other words, this is one way of expressing with a new query that we haven't seen before with the onDuplicate key syntax, essentially checking for the presence of a row or a value, and then acting based on that check all atomically, all at once. By contrast, if you had to do this manually, you would need to do a select to first find out if there's already a row for Google. Then you would do an update or an insert. This allows you to collapse a select followed by an update or an insert into just one query. So that's one way of doing this, but unfortunately, that is not enough. So thankfully, databases typically support transactions these days. So InnoDB is now relevant. The storage engine that we chose earlier for my database was InnoDB by default. That just means that's the format in which all of my data is stored. So what does that really mean? Well, that means I have a feature called transactions that I can use on that database engine type, but not on others. So how do you use transactions? You can do this. These 4 lines represent 4 separate SQL statements. The first, start transaction, and you can also say begin transaction. They're synonyms. That just means here comes a sequence of SQL queries that I want to execute atomically. In other words, execute all of these together or none of them. Do not interrupt any one of these steps with someone else's queries or anything like that. Put a lock on these rows. So update account set balance equals balance minus 1,000, where number equals 2. Update account set balance equals to balance plus 1,000, where number equals 1. What's the context here? It's kind of arbitrary, but imagine that I'm just trying to transfer $1,000 between 2 different accounts. One of those accounts' account numbers is 1. The other account number is 2. So this is one of those scenarios, much like the ATM withdrawal, that I want both the deduction from one account and the deposit into the other to happen together or not at all. Otherwise, I'm going to end up losing $1,000 accidentally or gaining $1,000 accidentally and not just moving $1,000 from one account to the other. Commit as the name suggests, means commit this transaction to the database. In other words, execute. So by saying start transaction, you're essentially telling the database to buffer up a few SQL statements. Once you do commit, it executes them all without letting anyone else squeeze inside there. What's also nice is that there's a command we can use that's sort of the opposite of commit. It's rollback. So this is another powerful feature of InnoDB, whereby, suppose we do the following. Start transaction, update one account, update the other account, and now you do a check. Select the balance from the account where number equals 2, and then with my hash sign there, I'm just proposing that we have some PHP code. It's in a comment because I just mean it to be pseudocode. Suppose that I screwed up. And after selecting the balance from account where number equals 2, now I realize, shoot, now the user has gone to a negative $1,000 or negative $1 even. I noticed a problem. And I want to undo every one of the steps that I just executed, whether it's 3 steps or 2 or 10. I want to undo these changes. It's like hitting Command or Control Z when you really screw up in an essay and you want to just go back, or in some programming code you're writing. So rollback undoes everything up until the most recent transaction. So it's wonderfully powerful and allows you to try to achieve some result. But if you can't, you don't have to figure out how to fix all of your various tables and cells based on the changes you made thus far. So wonderfully powerful, and it's also quite efficient, and it's in contrast to something called locks. So MyISAM for many years was the more popular default engine for MySQL. The upside of MyISAM is that it actually tends in certain benchmarks to be faster than InnoDB, especially for selects and sometimes writes, but you don't get the same property of having transaction support. But you do have locks. In MyISAM tables, which is just another option from that dropdown, essentially the data then is stored in a slightly different format. But if you want to achieve the same idea, you have to literally lock the whole table. So the syntax for that, which is less commonly necessary now, is lock tables account write. Now what does that mean? Account is the table name. And what kind of things do you want to prevent people from doing? From writing. So you can think of this as like the padlock on the fridge. You're preventing your roommate from writing to the fridge by inserting more milk into that variable. So this just means don't let anyone else can read the table. I don't really care, but I don't want them to write to the table here. So now I'm going to select the balance, and then I'm going to go ahead and update the balance, this time equal to 1,500, and then I'm going to unlock the tables. So in effect, you can do the same thing. You can say execute all of this stuff, and don't let anyone get in the middle. But the problem with locks in MyISAM is that you literally lock the entire table, which means even if someone wants to check someone else's account balance or someone else wants to make a deposit that has nothing to do with account number 2, the entire table is locked. So this tends to be bad for efficiency if you're essentially telling everyone, every other row, especially if you have a million rows, no one else can deposit money, check their account balances, or anything because I am blocking this whole table. Transactions in InnoDB, by contrast, effectively only lock the rows that you care about. So it's much better for performance, at least in terms of transactions. So that there's the trade-off. All right, questions? So let me come back to one thing that relates now to InnoDB as well. So recall that we were re-implementing these couple of tables for the example involving employees and products. And suppose now what I want to do is refine a little bit this thing here. Employee ID, recall we defined an index on it. Now why do we do that? For performance, really. It's a unique identifier. I might want to search by employee ID, so I made it an index. But notice this. I'm going to go down to relation view in phpMyAdmin, which is this link here below the table summary. And now notice that, whoops, did I not actually check that box? Let me go back. Let's see, employees we have. Oh, so here's how you look up what indexes you've created in my phpMyAdmin. I've clicked the employees table, and here I see a reminder of what the columns are called. If I click indexes, I'll see that this table has 2 indexes at the moment. A primary index on the employee ID field, and it's unique by definition of primary. And then remember that I also put an index on name, which was on the name column, and it's B-tree. That's an allusion to the tree structure that actually does that optimizes the searching. But now let me go back to orders, because I actually think I did not check the box correctly earlier, and look at my indexes. And indeed, okay, I completely screwed up earlier. I didn't mean to check select all of those things. This is a shortcoming of my memory and of PHP MyAdmin's interface. What I did here in defining an index, I defined it on all 3 fields, which was not what I intended. I wanted to have an index on each of the individual fields so that I could search on each field individually. This index suggests that I want to search on all 3 fields simultaneously. As with a where statement, like where product ID equals 1 and product equals table and employee ID equals 3. So that's not the kind of query I had in mind. So I'm going to fix this. Let me click drop next to this key, rather next to this index. And let me do this manually. So I'm going to go here and add a index. I'm going to go here and add an index, and over here and add an index. Unfortunately, PHP MyAdmin, when you do it all at once, apparently assumes you want a joint key. So now I have 3 separate indices, which is the intended behavior. And the URL, the link I'm going to click now is relation view. And this is another feature you get with a database like MySQL that you don't get with XML or with CSV or the like. Notice under relations, I can now define what are called foreign key constraints. And that's a feature of InnoDB only. In other words, I can now tell the database where these fields also appear. And the one I care about at the moment is employee ID. Notice here that under this checkbox, I have a list of all of the other fields I've defined in other tables with indices. And the one I want to do is I want to say that this table, this orders.employeeID field, has a relationship with the employees table.employeeID field. In other words, I have given this an index in the orders table, employee ID. And where else does employee ID appear? Obviously in the employees table, where it's a primary key. So if I want to teach the database that employee ID in the orders table is a foreign key, and what's a foreign key? Well, it's a field that happens to be a primary key elsewhere. I literally just make that association here. So now the database, MySQL, knows that employee ID is a primary key in employees, and it's a foreign key in orders. Well, who cares? Well, now you can set up rules for onDelete and onUpdate. In other words, by restricting this field in this way, I can now prevent developers, myself included, from deleting this employee from the database. Why? Because if Stephen, employee 3, has both a row in the employees table, and he's also sold a couple things in the orders table, by specifying this relationship between the 2 tables, I can ensure that I or a colleague doesn't accidentally delete Stephen from the employees table because I've restricted deletes and updates. In other words, if I try to delete Stephen, it's not going to be allowed because I'm going to be violating this constraint. By contrast, I can specify that I don't want to restrict those kinds of operations. I want to do something like cascade. And cascade is kind of the opposite. What this means is that if I delete Stephen from the employees table, you know what? Go ahead and delete Stephen from the orders table too. We're done with Stephen. If he's fired, that's it. We're going to remove all evidence of him. So this might not be the desired behavior. Sometimes it is, sometimes it isn't. But if you did want that behavior, where deleting from one table automatically triggers deletes from another, you can do this again all in the database. So what's the upside? Well, you don't have to worry about this in code. Whether it's PHP or some other language, your database can be self-managing in this way. So all you have to worry about is deleting the one thing you care about, Stephen, from the users table. And if Stephen's name or ID is anywhere else in your entire database and any of your dozens of tables, these kinds of operations can go through automatically and clean all of that up for you. Now again, probably bad for terminating an employee because you don't want to forget what they did actually sell. So we might instead want to do something like restrict in that case. But that's another advantage of InnoDB that you don't get from MyISAM. All right, so let's talk about design with an eye toward Project 1. So Project 0 is still in progress, presumably. Per the course's website, we'll announce tomorrow on the course's homepage how to submit it and the process for doing so. So keep an eye on that. You will need to submit it electronically. And then this second project, Project 1, is due next week. So realize there's deliberately this overlap so that even though Project 0 is not due till Wednesday, we'll release the next project on a Monday just so that you can manage your own time. And if you get a head start, great. If not, you can start on Wednesday or thereafter. All right, so CS75 Finance is the challenge at hand next. And this is your second project that actually involves MySQL this time around. So an actual database, no more XML. The vision for CS75 Finance, per the specification, whose PDF is already online, is to implement your own etrade.com-like website. A website that allows you to manage the buying and selling of stocks and to allow users to pretend that they're actually buying and selling real stocks. In other words, if I'm a user using your version of CS75 Finance, you're going to have to allow me to register for an account and then log into your site. And the moment I register, it's a nice little promotion. You're going to give me $10,000. And you're going to do that by associating that with me, my user ID, somewhere in your database. And then you're going to enable me to get stock quotes, like how much is Google right now, how much is Yahoo right now, or any other company, and then buy and sell stocks, so to speak. And how do you buy a stock? Well, you're going to check how much the stock currently is. And if I want to buy one share, you're then going to do the math. One share times stock price is probably a few dollars or a few $100s. Then you're going to check what's my account balance. I have $10,000 out of the gate. And then you're going to do the math and say, OK, now you have $9,000 something dollars, but you have one share of stock in some company. So the building blocks we've been looking at tonight in terms of locks and in terms of automatically updating rows and the like, it's definitely going to come into play here, especially since money is involved, where correctness is all the more important, because otherwise someone, you or the bank, are going to lose money. So the proposal we have here is this. First, take notice that here is the most recent piece of spam I got over the weekend advertising some penny stock. And this penny stock goes for 3 cents right now. Invariably, we have to change this example every year because these penny stocks keeps getting driven out of business. But this is an email I got, someone encouraging me to buy this penny stock. And a penny stock is one that's really cheap, usually some number of pennies. And this was 3 cents as of yesterday. So what's the relevance here? This is really just a screenshot of Yahoo Finance. What's nice about Yahoo Finance is that you can look up stock quotes like this one. ROSV is the stock symbol. If you're unfamiliar with buying and selling stocks, realize that the specification points you at a tutorial for them that applies to, that will give you a sense of how this world works if unfamiliar. But let me go to Yahoo Finance and type in ROSV, which again is the symbol for Rostock or Rostock Ventures Corp, whatever that is, and get quotes, and I see pretty much this. So it looks like it didn't really trade heavily today. In fact, 20,000 shares were actually bought or sold today, but the price remains at 3 cents. So this is nice and interesting, but what's really neat about Yahoo is that down here at the bottom is that they have this little toolbox. Because what we want to do is we don't want to resort to something like screen scraping, where to get a stock price from Yahoo, we have to grab their web page and then read the HTML and figure out what number in that mess is the stock price. Rather, here's a nice link, download data. So let's actually click this. I'm going to click download data delayed, and that's just a reminder that it's actually a few minutes delayed. It's not truly real time. Now notice this downloaded a file called quotes.csv. So this is nice, because now we can tie together last week's discussion of CSV and open up this file. It's going to open up a spreadsheet program like Numbers or like Excel. And what do I have here? Well, this is it. So it's a very simple spreadsheet, it seems, where the left-hand column contains ROSV. The next column contains 0.03, which is presumably the price. The next column contains today's date, and then the time. And then I'm not sure about those other fields off the top of my head because it's not actually indicated. But in the spec, we actually point out exactly how you can figure out what all the various fields mean. But the real important one for now is just the price. It's 3 cents. So what's the implication of having access to CSVs? Turns out it's really easy in PHP to write code that essentially pretends to be a browser, hits a foreign URL, gets back the result, and if it's great, if the result is in CSV, what function did we talk about last week that will actually parse a CSV file and hand you back an array? What's that? Not XPath. So XPath was only for XML, but there was a function that we talked about that can open a CSV file and parse it for you and handle all of the issues involving commas and quotes and the like. Lewis? Yeah, so fgetCSV. We didn't use it, but now is going to be our chance tonight to actually use this function to fetch the data and then do something with it. So we can pretend to be a browser, effectively downloading this CSV file. Why? Well, if we look at the Yahoo Finance URL, let's take a look at what it actually is. Let me go ahead and Control click and choose copy link address, and then paste this into a little text file. Notice that this is the URL that we just visited, download.finance.yahoo.com/d/quotes.csv question mark. The question mark is the interesting part because that means there's some dynamism. S equals ROSV and F equals a lot of stuff. So take a guess. What does the S HTTP parameter apparently represent here? Yeah. Search, or yeah, more concretely here though, what are you searching for, Isaac? The stock symbol. So S is presumably the stock symbol. Now, I didn't create this URL. Remember, I searched for ROSV and hit enter, but it appears to have generated later in that page under the toolbox a link that, you know, I feel like I can fake this, right? We already know that you can generate your own URLs or your own strings in PHP. Surely, I could copy and paste most of this URL, but just change which part of it in my forthcoming project. Just the value of S, yeah, just the value of the stock. Now, what does F refer to? That's another parameter, and I only know what those fields mean by looking it up in the documentation. We give you a URL online, but this is just some arbitrary sort of 1990s style thing from Yahoo where they have SL, I think that is, 1D1, T1. Each of those letters and numbers just represents a certain field, like the stock price, the date, the time, all of the columns we saw in our spreadsheet, they're derived from that cryptic looking string there, and some random guy on the internet figured out what all of these meant, and that's the URL we put in the spec. So you can go see what they all represent. But by default, we get back this. This last thing, ampersand E equals .csv, is actually a hack. Older browsers sometimes used to choke when you were trying to download something like a CSV if the file extension in the URL was not actually CSV. So even though this is not a file, this is probably a dynamically generated spreadsheet of sorts, a CSV file. It's not an actual file on a hard drive somewhere. That's just a silly little old school workaround for various browser issues that have largely disappeared, at least in this case. So what's the takeaway here? Feels like I should be able to copy and paste this entire URL and just change this if I want to implement my own stock trading website that allows users to specify stocks via my own interface. So let's take a look at an example here. Let me go into the appliance where I have this simple page waiting. This is one of the snippets of code available on the lectures page tonight for tonight's lecture. This is index.php. The functionality I've implemented in advance here is this. If I go here and type in GOOG as Google's stock symbol, doesn't matter if it's uppercase or lowercase for Yahoo, and then click submit, notice that this is what comes back. So as of tonight, Monday, it's apparently 574.92. Let's try another one. Microsoft, MSFT is their symbol. Submit. Theirs is 29.44. We can do something like Facebook. Submit. Theirs is 28. And so forth. Now, where is this coming? This is not hard-coded. This is generated dynamically by the server. So let's take a look now at index.php. Let me go ahead and open up index. And it's a pretty small program. In index, rather, is just my form. So notice this is where we were a moment ago. Where do I send the user when they submit the form? Just to be clear. Yeah. Quote.php. I'm using get just because I don't have to, but I chose to. Input name equals symbol. I didn't call it S, but not a big deal. I can call it anything I want. Type as text, and then a submit button. So that's it. And now, what's the next file obviously of interest? Quote.php. So let me go in there and open up quote.php. And this is how I go about getting the stock price. So notice at the very top of my file, I've got some PHP tags. So now I'm in PHP mode. Notice I'm next doing this. I'm URL encoding S. What does it mean to URL encode something? Yeah.
I think it takes all the spaces and turns it into like @20 and all that.
Yes, spaces are generally just simplified as pluses, but it would be %20. Yep, %20. So yes, URL encode takes a string and ensures that there are no dangerous characters or confusing characters for a URL's sake. What are confusing characters? Well, URLs cannot have spaces. So how are they typically represented? With a space character or with this cryptic sequence of %20. So URL encode does that. Now, is this a big deal? I just typed in GOOG. URL encode is not going to do anything to that string. It's not going to do anything to Microsoft. It's not going to do anything to FB. But if I typed in some weird punctuation for certain stock symbols, or I hit the spacebar accidentally, that would handle that kind of scenario. So this is just one of those, do it as a matter of principle. Anytime you send user input to a browser, you call HTML special chars. Anytime you send user input to a database, you call MySQL real escape string, or now the prepare function in PDO. Anytime you pass something to a URL, you should call URL encode on it. Those 3 rules of thumb. All right, so $URL is my next line in line 4. And notice I did literally what I promised. I copied and pasted the URL from Yahoo's website, and I put this little placeholder here of $S with the curly braces around it. The curly braces are not strictly necessary. It's just good practice that I've gotten into, just in case it's a complex looking variable, like a superglobal or an associative array. So that just means put the value of S there. And S, recall, was defined one line earlier to be the return value of URL encode. All right, the next line, what am I doing? This is what's great about PHP sometimes. It just does so many things easily. $handle equals fopen URL quote unquote R. Let's go in reverse order. What does the R likely mean? Yeah, read. So this doesn't really make sense in the context of URLs, because it's not like you can change a URL writing code on your server as opposed to someone else's. But fopen is generally used to open a file open. But PHP overloads a lot of these file-related functions so that if you instead give it not the name of a file that's in your current folder, but you instead give it a URL, it will open a connection to that server via TCP/IP. It will do all the requisite DNS stuff. It will get back the results of that URL and hand it to you in the form of a reference called a file handle. So that's what $handle represents. It represents essentially the return value from that server that represents the file that came back, which is hopefully an actual CSV. Now here's the function I promised we could use. fgetCSV takes a file handle. So it doesn't take a string, doesn't take a file name. It takes a file handle, which is the return value of fopen. So you have to do it this way. And it reads in the first row from that file. So you would have to call fgetCSV again and again and again if this spreadsheet contained multiple stock symbols. But as we saw, there's just one. So I'm only calling this once. So fgetCSV returns the first row. And what's the data type that comes back? Well, it's an array where it's a numerically indexed array where $row, open bracket, 0, close bracket, will represent the first column from the CSV. Bracket 1, the next column. Bracket 2, the next column, and so forth. So there's no notion of headers in a CSV. Sometimes companies or people will put the first row as having words for human friendliness. However, fgetCSV is not going to use that at all. So in fact, you sometimes want to call fgetCSV once to eat up that first line as being useful for humans, but not for machines, because it's the next row and beyond that actually has your data. But for us, so simple, because there's only one column or one row to worry about that came back from Yahoo. So I just call fgetCSV, and then for good measure, I call fclose on the handle to close that connection. I don't need anything more. Now, down below, I have some super simple HTML, and notice what I'm plugging in, the current price of this. Now, just to be clear, why am I calling HTML special chars on the symbol that the user typed into my little form? Yeah.
Well, for their stock abbreviation, they can type like script alert or get your cookies or whatever. So you want to state that.
Exactly. I want to protect against what we've been calling cross-site scripting attacks. So more on that again to come. But for now, we want to make sure that they've not typed in any dangerous characters or been tricked into typing in some dangerous characters. And now the interesting part, the current price of that symbol is, then some more PHP code over here. And what am I outputting? Row bracket 1. How do I know it's 1? I just looked at the CSV, right? We just opened it in numbers or in Excel. We saw that column 1, not 0, column 1 is the price. So I want to print that out. Now, there is a problem here. Like Jack's concern earlier about money could end up causing us some trouble. And if the price happens to be something like $1.90, maybe we would get $1.09. You'll have to actually experiment with some real stock quotes and see what kinds of numbers Yahoo's spitting out. But realize there's a function called number format in PHP. Printf in PHP, both of which allow you to format numbers to a specific number of decimal places, so you can guarantee that your money will be formatted in the right way. And back to our discussion now of databases. What were the data types that allow decimal points? It was float, double, and there's one other. Yeah. Yeah, it was called decimal, which doesn't exist in most programming languages, but this is a database field type that actually allows you to specify precisely the number of digits you want before the period and after the period. So for this, ultimately look in the MySQL documentation for more. It's very easy to use, but you'll be able to decide you probably want 2, maybe 3, maybe even 4 numbers after the decimal point. It really depends on what kind of precision Yahoo is returning. Is it just cents or is it fractions of cents? And as for how many numbers to the left of the symbol, the left of the period, you'll kind of have to make a judgment call. I mean, Google's like $500, so you need at least 3 digits. Berkshire Hathaway is sometimes $1,000, so you might need 4 digits, but you probably don't need 20 digits because that would be a really expensive stock. So you're going to have to make a judgment call there. But realize that decimal for money is probably your best bet because there's no imprecision. If you specify, give me 2 numbers after the decimal place, that's what you'll get. You won't get weird rounding issues as you would more traditionally. So realize decimal will be your friend in the database, and something like printf or number format will be your friend when it comes to the aesthetics of showing a human the number. All right, so that's how we can fetch stock queries, and that's it for integration. What's really nice here is that with CS75 Finance, you can integrate real-time stock prices into your application by just using this machine-readable format, CSV, which we all agree is kind of a crappy format. It's not very flexible. You can't sort of tag information very well. It's very flat. It's vulnerable to like commas and quotes being in awkward places. But it's at least machine-readable, and it's not something that we have to worry about parsing ourselves. So when we get back that value, we can just plug it right in, and we can now do it to perform math and buys and sells and the like. So a bit of a word on strategy then. So this website has to support these features. And the ... refers to other things that you might want to add by your own choice. So you're going to need to enable users to log in to your website. Now you have a bit of a chicken and egg problem here, because how are you going to implement login functionality before you actually have users? And again, obviously it's going to be you pretending to be a user or creating users. So you'll think through how best to approach this. If you want to implement login, well, you have the advantage of having seen like 9 different login examples thus far. Probably shouldn't use the earliest of those, which hard-coded John Howard's username and password. But the most recent ones, right, actually used a database. So you actually have code already from class that you can adapt for your own project to implement logins. Now, how do you implement registration? Well, registration is not going to use select from your users table. What keywords are going to use instead? Insert into, right? If you want to register for an account, you, the programmer, are probably going to have to call one or more insert statements to add that user to the table once they've told you their preferred username and password. Passwords, that's another design decision, right? We talked about not storing it in clear text, not the best practice. Should at least hash it, but using the password function might not be the best approach. So again, more on Project 1 in section tonight, but realize even though the functionality is maybe obvious, the implementation is meant to be non-obvious. A lot of interesting decision points to make. What I would propose in general is that if you want to implement login first, that's fine, and you should, but you can simulate registrations. How? Just use phpMyAdmin, right? Create your users table, literally click the Insert tab, and just manually insert some fake users so that you at least have some to play with. Then go and test your login code using those users you already inserted manually. Once you have login working, then you can actually implement register.php or similar to actually do those inserts. So realize you certainly shouldn't try tackling steps 1 and 2 and 3 and 4 and 5 and then test everything. You can absolutely do this step by just simulating certain things by using the command line or phpMyAdmin. So what about get quotes? Well, here too, you kind of have some code from class, right? How do you go about reading a stock quote from Yahoo? It's like 2 lines of code, maybe 3. So you at least have that module now, but that's a good candidate to write a function for it. So it's not going to be the only thing your file does. You can write a function that you then call. So you could have like a helpers.php file again, or something like that if you've gone that route for Project 0. So getting the quotes, relatively easy. Now selling and buying is less obvious. So why do I propose selling first? Create your portfolio table, or whatever you're going to call the table that keeps track of who has bought what. And how do you simulate buying stocks before you have that functionality? Use phpMyAdmin, right? Go to the Insert tab and just manually pretend like you bought Google in this many shares, or you bought Microsoft in this many shares. Then you can implement selling functionality. And do look at the spec, because we do specify what we mean by selling. We, for instance, don't let you sell fractions of shares. We specify that the user has to sell them all at once, so you don't have to sell just a few of them. But when it comes to buying, you're going to have to do a few things. You're going to have to not only get a quote right then and there, because you want it to be current. You're going to have to then check how much money the user actually has. So somewhere in this database, you have to keep track of my account balance, which initially we propose is $10,000. After that, it should go up and down based on what the user does. And you're going to have to make sure that if the user has already bought some Google shares, you're going to have to update that row in your database so that you don't just have many, many, many different Google rows when clearly you could consolidate them and just care about the total. So in short, there's going to be a number of other design decisions. But how many tables do we seem to be talking about already? Minimally?
Minimally 2, users and portfolios.
OK, users and portfolios. And what kinds of fields should probably go in the users table, even though there's many ways to do this? Yeah?
Username, password, probably email, and perhaps portfolio ID or something like that, balance, perhaps.
OK, good. So username, password, maybe email, or maybe that could just be the username, and some kind of unique ID, because you're going to want to correlate a user in the users table with a portfolio owner in the portfolios table, because what fields might go in the portfolios table? Your stocks. So one field is maybe the symbol of the thing you own. One field is the ID of the person who owns that symbol. And then what's probably at least a third field in the portfolios table? Yeah?
How many stocks you actually have on that account?
Exactly, quantity. Do you want to store the price in the portfolios table? Probably not, right? Because the price is going to change, presumably. So it's not like once you buy a stock, that's what it's worth. It's going to change day to day. Yeah?
Well, just looking at the stocks, you might want to actually store the purchase price because then you can calculate the difference.
Good.
If it's gone up or down.
So there is an opportunity, and herein lies the ... Maybe it would be a good idea to store the purchase price, recognizing that the current price will change, but then you can do some basic arithmetic and say your portfolio is up 50% or it's down 50%. But to do that, you have to know what the starting point or the starting price was. But there, realize you run into some design issues. Like if you're going to start storing the purchase price, now you might not want to consolidate rows in your portfolio table, because what if I buy a share of Google at $400, but another share of Google at $500? I want to somehow remember that one of those shares was 400, one of those was 500, or I want to store the average price or something like that. Now I have some non-obvious accounting issues to deal with. So realize in the spec, we do allow you to simplify certain things, but those are the kinds of trade-offs ultimately that you need to make. Any questions? So you'll actually find that it's pretty neat. Once you have things up and running, you can actually buy and sell these stocks and then check your portfolio the next day, because if you're querying Yahoo every time the user wants to look at their portfolio, as you'll have to, you'll be able to see whether things are going up or down. And certainly if you're buying like millions of shares of penny stocks or whatnot, you can actually see things change day to day. If there's actually a price movement and it's going from 3 cents to 4 cents, is actually a nice 33% profit overnight. But of course, this is just imaginary, and you're just doing the math, even though the actual volume of shares might not be consistent with reality. Any questions? All right, so why don't we officially wrap there? I'll stick around for questions. We'll let Chris get set up and dive a bit more into PDO in section, into Project 1, and into SQL itself.